All right, so this is the calculator part of the final Zoom review. Do you guys need me to work it, or have you had, I know with all your other classes, you have had so much time to look at it, right? Yeah. You know, chemistry doesn't take any time at all, right? Nobody's been having other tests this week, right? No, not at all, right? Okay, so this was the first section, so you probably don't remember this one. But I give you this formula on this, in this problem. Arc length equals the length of an arc. So this was a picture. So, okay, if we've got 120 degrees, it's going to be here. If this is a radius of 10 inches, this arc length, S, is going to be R times theta. The R is 10 in this problem, and theta is 120 degrees. But the only thing is, you're going to get 0 points on this problem if you just take 10 times 120. Why? Does you guys remember why? You probably don't want to. Because we have to convert it. Yes. You have to use, theta must be in radians. And if you want, so it must be in radians. So first you have to convert theta to radians. So theta is 120 degrees, that's times pi over 180. And then you can do that on the calculator by, you know, this is the calculator part, okay? Remembering whether it's the calculator part or not. Okay. So you can do 120 divided by 180. It's math, enter, fraction. So it's 2 pi over 3. So S is R times theta is 10 times 2 pi over 3. So we're going to do 10 times 2 times second. The caret is pi. And then we're going to divide that by 3. And I want the 2 decimal places. So, well, you could write this first as 20 pi over 3, and then it's approximately 20.94. There'll be answer blanks for you to put your answers in. So put your final answer in the answer blank. All right, if tangent x equals 4/3, and 180, and x is between 180 and 270, so 90, 180, 270. So we're in quadrant 3. Find the exact value of sine of x over 2. Okay. This is the half angle formula. All right, so we got to draw the picture in the right quadrant. Tangent is opposite over adjacent. So this is our angle somewhere in here. Opposite is bigger. Okay, so it is. So this side is -3. Opposite of this is our theta prime, our reference angle. This is -4. You need the negative sign. Okay? And this is a 3, 4, 5 triangle, so if you have that memorized, you don't have to show the work for finding that this is 5. If you remember the 3, 4, 5 triangle. Or else you use the Pythagorean theorem. -3 squared plus -4 squared is 9 plus 16 is 25, take the square root. Okay. Alright, so find the exact value of sine of the half angle of sine. Okay, so we are not gonna, cut. This is theta. We're not gonna cut that in half and go, okay, and draw a triangle. No, we're gonna use the half angle formula for sine. Okay, I probably should just be doing this on more paper. There's not enough room. Okay, so I got to get my formula sheet. I don't have these memorized. Half angle formula for sine. So here it is. Here's the half angle formula for sine. We're going to replace it with x. So we have to know how to use this though. So we have sine of x over 2 equals plus or minus the square root of 1 minus cosine theta divided by 2. And do I have more paper under here? Because we're going to go need it. All right, so how do we figure out what does this plus or minus sign mean? Does it mean we're going to have 2 answers?
No.
No.
Pick one based on the time.
Well, you look at the quadrant you're in to tell you whether to use the positive or negative.
Right. Look at the quadrant for x over 2. If it, this is x. Okay. And this is x over 2. Looks like it's going to fall in quadrant 2. Sine is positive in quadrant 2, so you use the positive. So for this sign, you use the fact that x over 2 is positive, and we did that with the picture. Unless you want to actually find out what theta is by doing tangent inverse and then adding 180 to it. Do you want to do that on the calculator? You can do that, but you still have to use the half angle formula. Use the half angle formula here. I can take my calculator and make sure that it's in degree mode. You want degrees mode, degrees. And I can find out what x is here. I can find what I label theta prime. It's going to be tangent inverse of 4/3 plus pi plus 180. So I get the second tangent inverse of 4 divided by 3. And then I add minus plus 180.
I actually like that better.
Okay? So this is how you can check your answer, not how to work this problem. Okay, so you can check your answer with this. X by the picture, we knew we had to add 180, is approximately 233 degrees. So half of that is 116 and a half or so. So x over 2 is approximately 116.5. And so my picture's right, it's in quadrant 2. But you still have to find the exact value. So I could then find sine of that answer. The answer is going to be, once we find it, it's going to be approximately 0.8944. That's the approximate answer. So now you're working a final and you can figure out the approximate answer by using that tangent inverse. So you see what I did? So this is how I make sure that my keys are right, especially on some of those tests we did. Finding beta and alpha plus beta and all that, I found the approximate values, added them together to see if I got the right answer to check my work. So you can do this to check your work, but you got to draw it in the right quadrant, because x is not the, I had to add a 180 to it, it wasn't, it's 233. Okay, and now we're going to find cosine of x, actually. Okay, I keep getting my x's and thetas, it's an x. We can find cosine of x, and is cosine going to be positive or negative here?
Positive, right?
No, cosine for x is negative in quadrant 3. Cosine is negative. It's cosine, just find cosine of x over here. Cosine x is adjacent over hypotenuse. If you have your signs right here, adjacent is -3. The hypotenuse is always positive, it's 5. Okay? So we're just going to plug that in here. So it's going to be the square root of 1 minus -3/5 divided by 2. And now you have to simplify that. So it's the square root of 1 plus 3 divided by 5 over 2. If this is under the square root, the whole thing. So to simplify that, you can use your calculator to help you to simplify it, but I look for some steps. Let's do it. We rewrite the 1, we need a common denominator to add. And we're going to write this as 2 over 1. Okay. And then we can separate, if you have this square root of AB, it's the square root of A over the square root of B. Okay, this is the part, if you get this is the concept, that's most of the answer. Then simplifying it is, you get 8 over 5 divided by, I'll just leave it under square root, okay, divided by 2 over 1. So 8/5 times 1/2, you flip it and multiply, and that's 1 divided by 2. So you don't need to multiply fractions, you do not need a common denominator. So you're going to take 4 times 1, so it's going to be the square root of 4/5. And that's the work to simplify it, and you're going to separate it. We could have separated it earlier, be fine too. but I guess this worked out pretty good. 2 over the square root of 5. And now to rationalize the denominator, we multiply by the square root of 5 over the square root of 5. So the answer is 2 square root of 5 over 5. And that's the exact answer. And I want the exact answer. Okay. Now on the test retake, I gave them a half angle for sine or cosine or something. And the actual answer ended up having like something like this. So this is the, if you get an exact answer, this, you might get this problem, the answer is that, but you might get a square root under a square root sign, and you can't simplify that, you just leave it. That would be an exact answer. The approximate, but that's an example. I don't remember what the test retake example was. But this is an exact answer for a different problem. Test retake. For the sine, and because if this ends up being a square root. So, but this one we can check. Just take 2 divided by square root of 5 on your calculator and see if you get the answer I said that this should be. 2 divided by second square root of 5. And did we get 0.8944? So you guys have, on this part you have your calculator. So it's easy to make a little mistake and not get the right answer, but you can see that that's the right answer. Okay. Any questions? I'll put up the rest of the work. So also you can have your calculator help you simplify. So you're able to use your calculator. So you can put this step, and then you can take your calculator and you can type in 1 plus 3 divided by 5. Enter, math, enter, enter. And so you can write this as your next step. See, 8/5. So if you guys struggle with fractions, which a lot of students do, don't be afraid to use the calculator to at least check your work. And a lot of people were thinking you needed common denominators to multiply fractions. So you can check, you can use your calculator to check your steps. And you don't have to show, you could go from this step to this one. And so you can type this in your calculator too. You can type this in your calculator, see what you get. All right, any questions? So that's the answer to the exact answer, and I want exact answers in the final. 2 square root of 5, unless it says round to 1 decimal place or something, or 4 decimal places or 2. And as you're working a problem, you should keep your decimal places. I don't know, on that take-home test, people were rounding sine of an angle to 2 places and then working with that and getting the answer slightly wrong. So keep at least 4 decimal places until the end of a calculation. I keep them all because the calculator remembers it. Are you not using an 83 that remembers your work? Well, you should be. You should be using the 83 or 84. It's required for this class. Using a calculator that doesn't show what you're typing in is really a bad handicap. But that's what I had to do. I used that. Okay. Any questions? All right. And then the next problem. So, you had one of these on test. This is test 3? I think it's test 3. So,
I think it was test 2 on.
test 2, okay. Oh, but this is x plus y. We're finding sine of x plus y.
Oh yeah, you're right.
So that is test 3.
You're right.
But it's using concepts you learned in test 2. So, and concepts from test 1. So we are really building on it. So do you need me to work it? Have you looked at the answer? You should draw your triangles in the correct quadrants, and that's part of your grade on this problem, I think. Double check that. It was on my test, remember? So the instructions say, draw and label the reference triangles. Reference triangles are against the nearest x-axis. So let's, do we need to work it? Probably. You guys aren't saying anything.
Of them, that's like what I like it because you have the formulas for it, yeah.
Okay. All right, so we're going to draw them in the right quadrant. Okay, in quadrant 1, sine is opposite over hypotenuse. Okay. I don't know. So this is a 3 over 5. So this is x. And so what's this side? It's a 4. You can find it with the with the Pythagorean theorem, because this is a right triangle. But that's a 3, 4, 5 triangle. You don't have to show your work if it's a 3, 4, 5 triangle. So if sine x equals 3/5 in quadrant 1, so that's a picture, and sine y is in quadrant 2, sine is 5 over 13. So on the key, it's 5. So this is not to scale. Okay. And you can find side A here by A squared plus 5 squared equals 13 squared. That's 169. A squared plus 25. But this is angle Y. So this would be Y prime, the reference angle. This is X is its own reference angle. Subtract the 25. A squared is 144, so A is 12. But it's negative 12 because of where it is. You go in the negative X direction, you need that negative sign. So there's our pictures. And now we're going to find the exact value of sine of x plus y. And you look it up on your formula sheet and carefully copy it without making sign errors. So, do I have a formula sheet somewhere? Yeah. Sine of alpha plus beta is sine, so it's sine of x, cosine of x plus cosine of, anyway, sine, cosine, cosine, it equals, I'm going to copy it, sine x cosine y plus cosine x sine y. And that's from your formula sheet. All right. And then you're going to replace sine x with what it is, 3/5. So now you need cosine of y. So you might want to figure out that cosine of y is adjacent over hypotenuse. So it's negative 12 over 13. You need the negative sign. Cosine of x. Well, cosine of x is again, it's adjacent over hypotenuse, 4/5. Four-fifths times sine of y was 5/13. All right, and you do not need to make this to be 65 and that to be 65 and this to be 65. You're multiplying fractions. You need a common denominator when adding fractions, and you can use your calculator to help you. But you're just going to you multiply the bottoms times the bottoms, the tops times the tops. So 5 times 13 is 65. 3 times negative 12 is negative 36. But you can use your calculator to help you with that. Plus 20 over 65. Now when you add fractions, you do need a common denominator. We have a common denominator. So this is just 65. You take minus 36 plus 20 is minus 16. That's your exact answer as a fraction. I want the exact answer as a fraction. What is that to an approximate number? Negative 16 divided by 65. So it's approximately, this is not part of your answer, but this is how you can check your answer on the test. 0.2462. Okay, so how can you check your answer with the calculator? Simply take the inverse sine of 3/5. So I'll write this down. X is approximately inverse sine of 3/5. And y is approximately inverse cosine of, inverse sine. We'll just use what they gave us, of 5/13. Okay, we're checking. Second for sine of 3/5. That's about 37 degrees, but I got it in degree mode. Okay, what's sine inverse of 5 over 13? And make sure it's in the right quadrant. That's about 23. And we can keep all those exact numbers if we want, but 23 plus 37 that's about 60. So what is the sine of 60 degrees? Did you get close to this? This was not exact. Sine of 60 that's one of our...
Pi over 3, right?
It's sine of 60 is square root of 3, 1 over square root of 3. So I added them together. I'm not getting anywhere close. Let me see. So I may have made a mistake doing this. Oh, well, guess what? where did I draw y? What quadrant was it in? Quadrant 2. Is 23 degrees in quadrant 2? So, you have to find this angle. My y prime is 23 degrees. So y is 180 minus 23. So you do have to know some information here. That's 167? No, 57. So 157 plus 37. Remember where it was, we didn't do it right. It's the wrong quadrant. This is quadrant 1. We're not going to give you 2 quadrant 1 equals. Okay? So sine, I'm going to run out of time doing this, but is it helpful to see how you can check your work?
Yeah. I mean, we also have it all on Chobi. I mean, E2L. So like, it's useful just to have that as well.
Okay, so I'm taking the sine and the, oh, and look, and you know, I didn't keep the exact numbers, but look, I got negative, I didn't keep all those decimal places, so that's why it's different, but to 2 places it's the same number. So, so you can't use this one. I knew that was not right. Sine of 60 is 0.866. So, okay, so that's how I check my work on the key. And it saved me many times. When I do 2 beta and alpha plus beta and the half angle, and yeah, so. All right, and you know, these are all posted. You guys, will be an identity, or more than one. Look back at your previous test 3. But here's an example, verify an identity. Okay, the most important thing, the first step you should do on verifying an identity is, for one thing, just manipulate one side at a time. First step, though, so we're not going to have equals 1 written each time. You may even write left side for me, so I can read these things. I had a hard time. But you're going to rewrite all this stuff in terms of, rewrite everything in terms of sines and cosines. Okay, so we have sine x divided by cosecant x. But cosecant x is 1 over sine. And we have cosine x divided by secant x. So we're going to use those identities. So this is going to be sine x times sine x, because cosecant is 1 over sine. Secant is 1 over cosine. Cosine x times cosine x. And we get sine squared x plus cosine squared x. And the angles are the same, so this equals, by the Pythagorean identity, 1. And so that's verified. So that's your first step. And then the second step is to look for, review these things, but look for the Pythagorean identity. A lot of you write those down on your test right away. That's great. Sine squared plus cosine squared equals 1, and then you figure out the rest. That's how I figure those out. I don't have the other ones memorized. I just figure those out. Okay, so the identities are similar to what you've had in the past on the final, but the other thing, third, is sometimes you may need a common denominator. So you gotta need a common denominator. And you may need to manipulate that. And those are harder, but these are definitely, and since it's a 2-hour test, look, I have a final from 9 to 11 with you guys and noon to 2 in another classroom. So, I can't give you much more time than an extra half hour if you need it. Because I gotta eat lunch and get over to the other final. So you gotta be better at this. We could start the final a half hour early if you want. You guys want to come in at 8:30 and start it? Does anybody want to do that?
I might do that.
I don't know. It depends on if they'll wake up.
You can bank on me showing up 30 minutes early. I'll do that.
Oh, okay.
Because I take a while, so I'll do that.
So that way, because I don't want to go from 9 to noon and have to go from here to that other final without any break.
Yeah.
So I could come in at 8:30. I'll come in at 8:30 for the final. If you don't want to show up till 9, that's fine, but you won't get that extra half hour. If you come at 9, you'll get the extra half hour. I know where you're taking.
Yeah. Okay.
Okay, so this really doesn't apply to you.
Okay. Just want to make sure.
Okay. Right? Okay. All right, so we worked that problem, verifying the identity, and then there's finding all solutions of each equation. So how did we solve this? We set this to 0. And okay, we solved for the trig functions here. We just have to solve for sine. So we just subtract the square root of 3 from both sides. So then we get 2 sine x equals minus square root of 3. Divide by 2. Sine x equals minus square root of 3 over 2. You have your unit circle. See the 2 places where sine is negative, square root of 3 over 2. And then you're going to write those 2 answers, but plus 2n pi, because the period of sine is 2 pi. And it said find all solutions. That's where, so you look at the unit circle, where is it equal to where's y equal to negative square root of 3 over 2? At 4 pi over 3 and at 5 pi over 3. Okay. All right. How many more do we have? I'm going to need to skip. Okay, let's do this double angle one. Everybody got messed up on this one.
Yeah, those are stupid.
Okay.
I don't like it.
If theta is 2x, sine of theta equals square root of 3 over 2, then what can theta be? What are all the solutions? Just list between 0 and 2 pi right now.
Pi over 3 and 2 pi over 3.
Right, pi over 3 and 2 pi over 3. So theta can be pi over 3 and 2 pi over 3, but theta equals 2x. And we want all solutions So we're gonna write 2x equals pi over 3 plus 2n pi, and 2x equals 2 pi over 3 plus 2n pi. And then we need to solve for x. Now dividing by 2 is the same thing as multiplying by a half. So if you want to write times a half, you know, that's the same thing. We're solving for x. I'm doing times a half because I don't want to do divided by 2 here. It's just a lot of work. Much easier to see that the 2's cancel here. You get x equals pi over 6. 1/2 times 1/3 is 1/6 plus n pi, and x equals pi over, the 2's cancel, pi over 3 plus n pi. All those 2's canceled here, and here, and here. These are all the solutions. If I ask for the solutions between 0 and 2 pi, then you're going to have to, you plug in 0 and 1, and you probably have the 4 solutions. You keep plugging in n equals 1, 2, but 2 is probably going to be, 2 is going to be too much. So if you needed the solutions between 0 and 2 pi, so between 0 and 2 pi, if you needed those solutions, you would let n equal 0 and then 1, and you will get pi over 6, and then you put 1 in here, and you get 7 pi over 6, and you have pi over 3, and you put 1 in here, and that'd be 3 over 3 is 4 pi over 3. These would be the solutions if the directions were different. Okay? All right, now this sketch, now we want you to sketch y equals 2 sine x. So we're going to sketch that. All right, so x and y, it doesn't have, its period is b, is 2 pi divided by b, is 2 pi over 2, because b is 2, is pi. It's actually a regular sign. It's going to be half of sine of x. The period is half. If the period's half, then the period divided by 4 is pi over 4. So your 5 key points, you start at 0 because there's no phase shift. Then you add pi over 4. Then you add pi over 4 again. Then you add another pi over 4. And then you add another pi over 4. So this had no phase shift, so you're starting at 0. These are the 5 key points. So sine is 0, and then it's 1, and then it's 0, and then it's 1, negative 1, and then it's 0. The regular sine function. You can use your unit circle to help you with that. So if we want to just show up to pi, if it has to show up to 2 pi, you're going to show, go the rest of these. But you're gonna have 0 and then say this is 1. This is the sine function. And label the values found above, or mark them with a star or a dot. Well, I already put dots in, so I'm going to mark them with a star. Pi over 6, this is pi, this is a half pi. 6, that's way over here. This is pi over 6. So this point would be pi over 6 square root of 3 over 2. This point here would be pi over 3, I guess. Okay, and if we kept going, you know, we'd have another set. If we had to go to 2 pi, we'd have another set here. 3 pi. We'd have another set here and here. That would be the pi, 7 pi over 6 and the 4 pi over 3. Okay, find the angle of elevation in a right triangle. So, just got to remember the angle of elevation from the horizon up, so that's our angle. Tangent theta then will be 100 over 27. Theta will be tangent inverse of that. Just type that in. If it asks for degrees, then give it to me in degrees. If it asks for radians, it'll ask for the certain item. And if it doesn't ask for, then label your answer with a degree symbol if you use degrees, and write radians if it's in radians. All right. If you're given a triangle with 2 sides and an angle, find the angles A and B using the law of cosine. So law of cosine, okay, and you got the rest of this. So what questions do you have in the last few minutes here? I've got the answers posted.
Could you do the conversions in number 21 real quick?
21, okay. All right, so sketch the polar coordinates for 3, 4 pi over 3. Okay, so 1, 2, 3. All right. 4 pi over 3 is 1 pi over 3, 2 pi, 3 pi, 4 pi over 3. That's our angle, and then from our angle we go 1, 2, 3. So this is the point 3, 4 pi over 3. Is this what you want me to do?
Well, more so the conversions of like rewriting them as equivalent.
Oh, okay, okay.
Because I got different figures than you.
All right, well you can. You have your choice. We can write it as it's easiest to leave R positive. If I don't tell you you have to make it negative, let's leave it positive.
So you to add 2 pi?
You can add 2 pi, you can
So you don't.
you can use the negative angle, so this equals 3 negative 2 pi over 3. It equals 3 4 pi over 3 plus 2 pi.
10 pi over 3.
is 10 pi over, so you.
Okay, so you don't need the 3 that you
If
got.
if it doesn't say, it's just asking for a different one.
Okay.
There's multiple answers,
Gotcha. Simple enough.
okay? There's a lot of people were getting messed up with the negative sign on R though.
That's when you add just pi, right?
Okay. The negative sign on R means you go to the angle is 3 pi over 2. 3 pi over 2. The angle's here. If this is 1, that's 3 pi over 2. Our point, though, because it's a negative 1, it's here. So to write that as a positive, you could write 1 pi over 2. That's it. Okay, so you go by the angle, and if it's a negative R, you start at the pole and go negative direction, opposite that angle. All right, convert to polar, convert to rectangular, convert to polar. You need to use the formulas. It says to use the formulas. On this 122, you got to draw the picture to make sure you get it right. It may not tell you to draw the picture, but if you don't draw the picture on 22, you can draw pictures whenever you can. If you don't draw the picture, you're likely to get it wrong. And that was part of the step. Draw the picture. So negative 2, positive 2. There's the point. This is negative 2, positive 2. R is the square root of 2 squared plus negative 2 squared. 4 plus 4, 8, square root of 8. 2 square root of 2. So, R, I'm using the formula, it's on your formula sheet, that R is the square root of x squared plus y squared. And then tangent of theta equals y over x. So y is 2, x is negative 2. So that's negative 1. And look on your unit circle, where's that? That's at negative. And we've got it. If we do tangent inverse of negative 1, we get negative 45 degrees, but that's not the right quadrant. Remember, we wanted to make this, there's many polar coordinates that work. Theta must be the smallest angle, and it's positive. And look where we drew it. So we need to, this is our theta. So if this is, our reference angle is then 45 degrees, so take 180 minus 45, theta is 180 minus 45. Is that 135? Yeah. Then write it as an ordered pair. 2 square root of 2. Oh, and we wanted if we wanted it as 3 pi over 4 or 135. It'll tell you whether it wants it as radians or degrees. I have radians written on my key, but it depends what this problem didn't say. All right. And then there's vectors. Any questions about the vectors? So find the resultant of 3 vectors. The resultant means you just take u plus v plus W. I stressed that in the lecture. Just, that's the resultant. It means add the three vectors together. And they'll be written in terms of I and J. You don't have to draw pictures. Okay? See you on Tuesday, and I'll get here at 8:30.